So the topics that we're now moving on to are all about using the skills that we've learned on how to solve equations and using them to and applying them to different areas. So the first thing we're going to look at is solving single inequalities. And we do exactly the same as what we did with equations. We just need to make sure that we keep the sign the same. So I know that at the end of this, I'm going to have that same sign down here as I started with. So down here, I'm going to write the less than or equal to symbol. Now, once I've done that, all I need to do is use the flow diagram that I used before. So here, this tells me I'm timesing by 3 and adding 1 to give me 13. So x times by 3 plus 1 gave me 13. So going back the other way, subtract 1, divide by 3, and it gives me 4. And rather than writing at the end x equals 4, I know that for this to be true, x must be less than or equal to 4. So as long as I choose a number x which is less than or equal to 4, I know that 3x plus 1 is less than or equal to 13. And it's exactly the same with the second example. I'm going to do, again, first thing I'm going to do is just put out my symbol down there just to remind myself that I know it's going to end up being less than or equal. Start by multiplying out your brackets. 3 times 2x is 6x. 3 times 7 is 21. So I've got 6x plus 21 is less than or equal to 9. Use my flow diagram. X times by 6, add 21, 9. Going back, take away 21, divide by 6, gives me x. 9 take away 21 is going to give me minus 12. Divided by 6 is going to give me minus 2. So here I've got minus 2, and x must be less than or equal to minus 2. If x is any number which is smaller than or equal to minus 2, then I know that here I'm going to end up with an answer which is less than or equal to 9. Okay, last one. Here we've got the x's on both sides. So again, I'm going to use my bouncing method. I'm going to bring the 3 over to the 7 to keep it positive. So that's going to become a minus 3x. 7 take away 3x will give me 4x. Take away 5 is greater than or equal to 11. So I know that here I'm going to have a greater than or equal to sign at the end. Got x times by 4, take away 5, gives me 11, working backwards, add 5, divide by 4. 11 add 5 is 16, divided by 4 is 4. So I know the answer is x is greater than or equal to 4. And if I needed to, I could represent any of those on a number line. I could give some examples of numbers which were, for example, greater than or equal to 4. And it could, for example, ask me what's the smallest possible multiple of 5 that would satisfy this equation, and the answer would be 5. Okay, pause while you take down the video, and then we're going to have a look at some questions for you to try. Okay, so there's 6 questions here. For all of them, I'd like you to get to a position where you've got x is less than or equal to, x is greater than or equal to, x is less than or x is greater than. And then for questions 3, 5 and 6, it asks you to find some specific information about it. So for question 3, it asks you to show your answer on a number line. For question 5, it asks you to find the largest. Question 6 asks you to find the smallest. Pause the video now, have a go at the questions, and then unpause to get your answers. Okay, so just going to run through the solutions now. X is less than or equal to 4 for the first one, and x is greater than or equal to 7 for the second, because you added 3 and divided by 2 to get 5, so times by 2 is 10, take away 3 gives you 7. Here we've got an answer of x is less than or equal to 2. Showing that on a number line, you need to make sure that it's filled in to show that it's not a strict inequality, it can be equal to 2, and it goes down to the left, so x is less than or equal to 2. Part 4, you've got x is greater than 4. We started by bouncing the 2x over to the left-hand side. For part 5, you would have got x is less than or equal to minus 3.5. So looking at that on a number line, there's minus 3.5. It's going down to the left from here. The largest possible whole number then that it could be would be this number here, which is minus 4. Here you've got x is greater than 5.5. The smallest possible whole number, the smallest possible integer there would have been 6. Give yourself a mark, please, out of 6 for that.